In today's lesson, we are going to be looking at section 1.3, solving nonlinear systems by graphing. So we're going to start by analyzing a 2 by 2 linear system. Sketch the lines given by the system x plus y equals 6 and negative 3x plus y equals 2 on the same set of axes to solve the system graphically. Okay, so I'm going to start by graphing these two linear equations. In order to do that, I am going to solve each one for y. So my y-intercept here is 6. And my slope is going to be negative 1. So I'm going to go down one, right one, down one, right one. Now, in order to solve something by graphing, it is very important that you have an accurate graph. So please make sure that you're using a straight edge to draw your linear equations. Let's do the same with the second one. Negative 3x plus y equals 2. If I solve for y, that's y equals positive 3x plus 2. So now my y-intercept is going to be a positive 2. And my slope is 3. So I'm going to go up 3 to the right 1, up 3 to the right 1. And again, now I'm going to use a straight edge to connect these points. And as you can see from my beautiful graph here, they do intersect at one nice ordered pair. And that ordered pair, which is right here, is going to be 1. And that's up 1, 2, 3, 4, 5, 1, 5. That is my intersection point for my two lines. So when the question says, how many solutions are there to this system? There's only going to be one, because there's only one spot where the two lines overlap. Let's look at a second example. Sketch the lines given by the system x plus y equals 6 and x plus y equals 2 on the same set of axes to solve the system graphically. So let's approach it the same way. I'm going to solve each one of these equations for y. So I have y is equal to negative x plus 6. Starting again with my y-intercept, which is a 6. And my slope again is going to be negative 1. Using a straight edge to draw it, the line that connects those points is going to look like that. Let's look at the second equation. X plus y equals 2. So y is going to be negative x plus 2. Starting now at my y-intercept, which is 2, my slope is going to be down one, right one, down one, right one, using a straight edge. Whoops, sorry. That one got a little crazy. It is going to look like that. Now, that's interesting. If you look at these two lines, they do not intersect. And the reason they do not intersect is that these slopes are the same. If they have the same slope, hopefully you remember from geometry, that means that the lines are parallel. And parallel lines never intersect. So how many solutions are there to this system? There are no solutions, because the two lines do not cross. So when you're trying to decide a solution for a system, you are looking for where the two figures, lines, parabolas, circles, whichever you are drawing, where those two functions overlap. Let's look at one more example. Sketch the lines given by the system x plus y equals 6 and 2x equals 12 minus 2y on the same set of axes to solve the system graphically. How many solutions are there to this system? Let's start again by graphing. Now, as you notice, this is the same linear equation. At a -1 slope, y-intercept of 6. Using a straight edge. Let's look at my second equation. 2x equals 12 minus 2y. Now, I always like the y terms on the left, so I'm going to add that y term over, which would give me 2x plus 2y equals 12. So 2y is equal to negative 2x plus 12. If I divide all my terms by 2, that's going to give me my y's by itself, a negative x, dividing each one by 2, plus 6. Well, this is interesting. If I look at these two equations, what I'm noticing is that they're actually the same, which means when I graph this second line, it should overlap the first line. Stick with that red color. That being said, all of the ordered pairs on the blue line and all of the ordered pairs on the red line are the same, which means these two equations, the ones that were given the original system, are going to overlap, meaning that there are infinitely many solutions. We are now going to look at an exploratory challenge. Suppose that instead of equations for a pair of lines, you were given an equation for a parabola and an equation for a line. What possibilities are there for the two figures to intersect? Sketch a graph for each possibility. This is a really interesting scenario. So if I am looking at a linear equation, we know that it is going to be in the form y equals mx plus b. If it is slope-intercept, you may also see it in standard form or point-slope form, but we're going to stick with this form that we have addressed in the other examples. But anything that's in that form is going to look like a linear equation. Now, a parabola is given by a y equals x squared equation. Now, sometimes you see it in vertex form, you may also see it in standard or factored, but the graph that represents any sort of quadratic is a parabola. So we're looking for all the different ways that these two shapes can intersect. Well, let's say my parabola looks like this. Is there any way that I can draw a line that were intersected at 2 points, which would give it 2 solutions? So I would like you to pause your video and think about that question. Well, let's see how you did. That's my parabola. My job was to try to draw a line that would cross that parabola at 2 spots. So my mind immediately went to something like this. If there are 2 intersection points and that line can have any slope, that means there are going to be 2 solutions. Well, let's think about, is there any way that I can draw a line that would intersect this parabola at only 1 point, which would give me 1 solution? Please pause your video and think about that question. Okay, well, I thought immediately about a horizontal line. A horizontal line here, let's pretend that's horizontal, is going to cross at the vertex. And in geometry, you should have learned that that means that the line is tangent to the parabola. So that's going to give me 1 solution. Now, there are a couple other ways you can draw that. and your parabola can open down as well. But maybe I want it just to intersect right here, which again would look something like this, intersecting it at that spot. Several different ways I could draw it, building off that, again, similar, opening up parabola. Maybe it would look like this, again, being tangent. Well, are there any other ways that I could draw this? I don't think it's possible to have three solutions because that means that my line could no longer be straight. But you know what? It is kind of neat because I could draw this where they don't intersect at all. So maybe this is my parabola and my line looks something like this. If the two shapes do not intersect, then that means that there are going to be zero solutions. Okay, one last scenario. Suppose that instead of equations for a pair of lines, you were given an equation for a parabola and an equation for a circle. What possibilities are there for the two figures to intersect? Sketch a graph for each possibility. Okay, so we're now looking at a circle and a parabola. Well, let's say my circle looks like this. I'm now going to look for different ways that I can draw a parabola that may intersect it either no times or one time or two or three, etc. Pause your video, please, and see all the different ways that you would be able to draw a parabola that may intersect that circle. Okay, let's check this out together. My first thought was that I might be able to draw a parabola that would look like this. And a parabola that opens up, if that were my circle, this would intersect it two times, which would give me two solutions. Now, there are other ways I could draw that as well. I could also draw that circle. Where maybe the parabola looks like this. Again, it's intersecting at two different spots, which means it would have two different solutions. Now, the parabola can open up, the parabola can open down. You have lots of variations of those graphs. Well, maybe I could draw my circle and it would only cross it at one point. Well, I'm thinking about it looking like this. If my parabola were open up, I could draw my vertex on the circle. That would only give me one solution. Well, maybe you came up with some different sketches. Let's say this is another circle. Can you draw it so that they would intersect three times? Well, if it was three times, it might look something like this, where this branch is going to intersect it and possibly this branch would intersect it. So I'd have an intersection point here, here, and here. That would give me three solutions. Are there other ways that I can draw these two shapes? Well, you know what? I can actually draw it like this. Maybe the parabola still opens up and it intersects it four times. All of these intersection points would count as solutions. You may have had some different ones, but those are the ones that pop out in my mind. This last slide is outlining some of the things that we just discussed. On the top, it's talking about several different ways where you may see a line and a parabola being drawn. It says when a nonlinear system consists of a linear equation and a quadratic equation, the graphs can intersect in 0, 1, or 2 points. And it gives you some different sketches that we drew, possibly a little bit different. On the bottom here, it's talking about some other shapes that you may not have seen yet. You have a circle. Down here, you're looking at what's called an ellipse. This has an ellipse as well. And many of these that we are going to look at during this unit can intersect several different times. So this first one, I have a circle and a parabola. They don't intersect at all. So that would give them 0 solutions. The one on the right, these intersect one time. I have 2 parabolas opening up. The one solution could be seen here. On the bottom, I have a red circle and a blue ellipse. You can see that those 2 shapes intersect here and here. Middle one, you have 3 solutions, and you have an ellipse, and you also have a parabola. These are the 3 places that they cross. And again, the last one that has 4 solutions, you have a pink circle and a blue ellipse crossing of these places. Now, there are so many other scenarios that you can look at, but in this unit, we are going to be looking at how to graph nonlinear equations and all the different ways they could intersect.